All right, new chapter. This chapter is all about transformations, and this first one's going to be about translations. But this is not, it's not tricky stuff, guys. This is actually pretty straightforward. Objective: students will be able to translate points and shapes and determine the translation given an image and its pre-image. Simple stuff, guys. So the first off, let's talk about this first word here. A transformation is a general term for 4 specific ways to manipulate the shape of a point, a line, or a shape. So we got 4 ways we can do what's called a translation, which is what this video will be about. And then we can do reflection, which is 8.2, rotations, which is 8.3, and then dilations, which is 8.4. So we just have these 4 ways to basically maneuver figures around a geometric plane. And these 3, let me highlight them. These do what we call preserve congruence. And we'll talk more about that later. But basically all that means is when you translate it, reflect it, or rotate it, it will still stay the same shape. It's not going to change its size or shape, but a dilation actually changes its size. And so that does not preserve congruence. It only preserves similarity. So actually we could say these preserve congruence and what we call similarity. Similarity is when two figures have the same shape but different sizes. And then we could say that this one, dilation, that only preserves similarity. Again, we'll focus more on this later. All right, so let's talk about translation. What is a translation? So a translation is a process of moving one point or image from one spot to another by sliding the image. So that should just say 1. Sorry about the ones there. One spot to another by sliding the image. Literally just taking an image and shifting it. So you can see right here, we call this the pre-image. That means this is where it started. And if we slid it up and to the left, that would be a translation. So the pre-image, the image before a transformation, the image that's after the transformation. And what we normally do is we will write down the pre-image points. So if I have my pre-image here, these points are a little bit hard to tell, but let's just say this point right here. That point, let's say we call that A, and let's say we call this B. I'm not going to write down all these points because it's a lot. And let's say we call this point, we'll call this one right here C, okay? So we label those points with normal old letters, right? A, comma B, comma C, and there's obviously a lot more points than that. Well, then when we go to write the image after the translation, we're going to label these as A prime, B prime, C prime. And so this little apostrophe tells us oh, okay, this is the point after it shifted, and this is before it got shifted. And we can even do this. So for A, let's take a look. So if A's coordinates looks to me like it's at 2, -2, and where would that same point be up here? Well, we know it's on this middle left, so it's this point right here. So I'm going to just circle that. I'm going to say, well, that would be A prime, right? And this right here, this would be B prime. And this right here, this would be C prime. And so A prime's coordinates, we could find those. We could find all the coordinates, but I'm just showing you one for now. A prime's coordinates appears to be -2, +5. And then you could do some basic math. So if it started at +2 and went to -2, that means it shifted to the left 4 units. And if it started at -2 and went up to +5, that means it shifted up 7 units. And that's all a translation is how did it slide or shift along our graph. So to move an image up, you add to the y value. To move the image down, you subtract from the y value. So let's say, for example, we were going to translate down 2 units. Okay, and let's call this, I'm going to call this point P. Okay, so we say P has a coordinate of -2, +3. And if I was going to shift it down 2 units, what you can kind of do is you can just kind of like add what's going to happen to it. So the translation would be, we're not moving the x at all, and we're going down 2 units in the y. And that would make P prime be the -2. The x doesn't change, it's still -2. And 3 minus 2 is 1. And so P prime would have to be right here at -2, 1. And that makes obvious sense here, right? Doesn't that look like what P would be if we shifted it down 2 units? Easy peasy. That's all we're really doing. Okay, and to move an image, this is going to bleed over to the next page. Right, you add to the x value. To the move the image left, you subtract from the x value. Okay, so let's go to the next page here. And let's say I was going to take this point, P again, we'll call it P still. And let's say we're going to move to the right 3 units. Okay, so P still starts off at -2, +3. And now I'm basically going to just add, what am I doing? I'm going to add it to the right 3 units. I'm going to add to the x value 3, but I'm not changing the y this time. And so P prime would be -2 + 3 is +1, and then 3 + 0 is still 3. And so that coordinate would be at 1, 3, and sure enough, that's right there. That's to the right 3 points. Okay, we have lots of different ways that we could talk about these translations. This is kind of what you'll see a lot of, like just saying, hey, here's what it started, here's what you're doing to it, you're subtracting a. And really this should be written as like plus or minus, because you could be adding or subtracting to it. And that's how it's going to shift. You can also just write as like this. So for example, above, let's say I was shifting it 3, 0. I would say, okay, I'm going to take the x value and I'm going to add 3 to it. I'm going to take the y value and I'm going to add nothing to it. Or if I was just writing this as a translation, I would just say the translation is going to be 3, 0, because I'm going to translate it 3 units to the right and 0 units down. And then you could also write as a vector. I don't think you're going to see this very often, but really it means the exact same thing as all of these. It's just different ways of writing the same stuff. So, for example, a translation that moves 4 units to the right and 3 units down can be written as, well, let's do the first one, the algebraic notation. If I'm doing 4 units to the right, that means I'm going to add to the x. And if I'm going to do 3 units down, I'm going to subtract from the y. Boom. Or I could say that's just a translation of 4, -3. Or I could do vectors and just say 4, -3, add little vectors. All the same thing, just different ways of writing the exact same thing. Okay, so we're going to do some example problems now. What I want you to do is go ahead, pause the video, and just graph these 3 points and then connect the dots. Okay, if you graphed it correctly, it should look something like this. Here's point C, A, and T. And then what it says is that you are going to use the rule 1 unit left and 2 units up, and then write the translation rule. Okay, so here's what I'm going to do. I'd like to just plot out all my points. So we're going to write C, and C is at 1, -2. A is at -2, 1. And T is at -3, -3. And the translation they want us to do here is they want us to do 1 unit left, so that's -1 on the x, and then 2 units up, and that's +2 on the y. So essentially, we're just going to basically add these to each of these. So what would C prime be? And I probably should have just done all this in blue because I wrote it in blue, but we're going to do C prime and all the translations, so I did the pre-images in blue, I'm going to do the images in red. So if I translated this, we would end up with C prime. And we can really just do this as mental math. -1 and 1 makes 0. And -2 and 2 also makes 0. Okay, so that one's going to move to the origin. And then A prime is going to become -1 and -2 makes -3. And 2 and +1 makes 3. And then let's do for T prime. -3 and -1 makes -4. and -3 and +2 makes -1. And then we could go through and we can plot all these points. So let me zoom in here a little bit. We'll plot all these points. So 0, 0 for C, that's going to be right here. So that's going to be C prime. And then A becomes -3, 3, or A prime, I should say. And then T becomes -4, -1. So that's right here. There's T prime. And then we can connect these dots. And sure enough, it sure looks like everything shifted up 2 and back 1, which is what they wanted us to do. 1 to the left and up 2. And then we could write the translation rule. I kind of wrote it right here. I guess the proper way to write it would be like underscore. Or we could have, again, said like a vector format. Or we could have said that the translation rule is going to be x minus 1 and y plus 2. Lots of different ways we can write it. All means the same thing. Okay? Now let's go to example 2. Write the algebraic rule to describe the transformation. All right, well, look, we have C, C prime, O, O prime, L, L prime, D, D prime. Really, we should only have to look at one of these to figure it out. Any one of these relationships should give us the same one. So I'm going to do the easiest one here first. I'm going to say O to O prime seems the easiest. And it seems like what we're doing here is we're taking the x value and subtracting 2 from it, and we're taking the y value and adding 0 to it. Now, you don't actually have to write the plus 0. You can leave it like that. And I'm just going to check and see if this is true for all of them. So the y's do seem to all stay the same. And am I just subtracting 2 from each one? 2 minus 2 is 0, -5 minus 2 is -7, -2 minus 2 is -4. Yes. So there we go. I have the rule. Boom. Easy peasy. That's really all there is to it. This is probably the easiest one of the 4 transformations, but none of them are really all that hard. So don't be stressed about it. Don't forget to write that question at the end of this video, and I'll see you guys on the next one.